time. All right, so here we are. We're in section 7.7. That's the game plan for tonight, right? 7.7 and 8.1. Those are both going to be due Sunday night at midnight. So you got just under a week to get those done. I'm going to try to cover those right now. And then quiz 4 is actually due sooner. But that's review stuff. Remember, the quizzes are always over old stuff. The quiz won't have any of this stuff we're doing tonight on it. The quiz is always over the previous week's stuff, just to keep things fresh for you. So that would be the 7.5, 7.6 stuff that was due like last night, right? Sunday night? All right. So, all right, here we go. How do you simplify complex fractions? What do you do with a complex fraction? Whoops, kind of messing it up there. Fraction over a fraction. Does anybody know how you handle a fraction over a fraction?
You multiply by the reciprocal of the...
Yeah, right. 1/4 times 12/5. Yeah, dividing is upside down multiplying. Exactly right. Dividing is upside down multiplying. Have you seen that kind of thing before? So dividing by 5/12 is the same thing as multiplying by the upside down. Is that good? And then, what do we do from there? How do we multiply 1/4 times 12/5? You can cross cancel, huh? Remember cross canceling? 4 goes into 12 3 times. So we get 3/5 and we're done. That's the answer to that one. You good? You want to try number 2? Go ahead, try number 2. Number 2. The top stays as it is, huh? 8 plus x over 9 times, and then what do we do with the bottom? Got to flip it, because dividing is upside down multiplying, isn't it? So times 7 over 8 plus x. Whoops. And then we cross cancel 7/9. Is that good? So dividing is upside down multiplying. So far. Okay. This one, let me have this one. This one is tricky. We can't just do the same thing where we take the denominators and flip them. Why not? Well, have you heard me say, I can't remember what I said when I haven't said, pluses and minuses, I do the Costco talk and glue things together, right? Pluses and minuses make everything hard, basically. Pluses and minuses glue things together, making them a package deal, so you can't do just one of them. So, and you can't do anything nice, basically. So what I mean is, look back for a second. See how on number 1 there was no plus or minus. Number 2, well, there was a plus there, but there wasn't two separate terms on. There were not two separate terms on the top. See how here on the top we have two separate terms, separated by a plus sign, and on the bottom we have two separate terms. What that means is you can't flip them independently. You can't just say, because you might think, well, can't I just grab that? And flipping 1 is just 1, and then flip the 7/3. It's not right. It's not true. You could prove it with numbers. You can't just flip them independently like that. That's not really the upside down of them. Anyway, so what do you got to do then? So when there's two terms, let me just write it out for you. When there's two terms on the bottom, added or subtracted, like these guys, we must well, let's just say we must multiply all terms by the LCD. That's how you have to handle it. Because you can't just flip the bottom when it's two things like that. It's not true. Okay, so what do I mean by the LCD? Well, I mean you look at all the fractions involved. Here I've got a 14, here I've got a 7. So you look at that 14 and that 7. What's the LCD for 14 and 7? It's 7, huh? I'm sorry, it's 14. It's not, you got me going. It's not the GCF. Yeah, let me mention. It's not the GCF. I know we just came out of a big factoring chapter and you guys are really spring-loaded to go 7. But that's the common factor, which is the opposite of a common denominator. You know what I mean? The 7 and 14 is kind of like, what if you had two denominators, 1 7, 1 14, that you wanted to add? What would be the common denominator? 14. Yeah, the bigger one. Everybody tracking with me? There's two things we've been doing in the last 3 weeks or a month or whatever, and that is common factors, GCFs, and that's a tiny, if I was factoring and I had, like 7x plus 14, yeah, I would take out a 7, that's a 7, take out a 7, that would be the GCF, but that's not what we're doing here. When you're talking about fractions, you're talking about common denominator, so that's going to be 14. So what do you do with it? You multiply 14 there, 14 there, 14 there, and 14 there. Everybody gets one. So I mean multiply all the terms by the LCD. That's what you have to do. It's longer. Things are always longer when we have pluses and minuses. Okay, so let's carry that out. What happens? Well, 3 times 14, just use your calculator if you need to, 42. Now what happens right here, plus, the 5 14ths is going to multiply 14. What's going to happen there? Yeah, because right, it's going to become 5, right? Because whenever a whole number, like 14, interacts with a fraction, it's over 1, right? Over 1, boom, 5 like that. Is that good? And then 14 times 1 is 14. And then 3/7 times 14. Same thing again, right? When a whole number interacts with a fraction, put it over 1. You okay there? 7 into 14, 2 times. 3 times 2, 6. On that, yeah.
Would it work if you just if you add the numbers?
Yeah, you could add them first. Now, in just a second, they're going to be x's and y's. They're not going to be addable. You know what I mean? Like, what if that was 1x and 3/7 y? Then they're on like terms.
And then you turn it into an improper fraction.
Improper fraction? Well, yeah, I better move on. There's other good ways. And some are right, some are not. We'll see as we go. That is okay for now. That is true for now. 47/20 is our final answer. Is that making sense, what I did there? On that? I would encourage you to do it this way. Because I hear what's being said as far as doing that. I think this will be easier for you. And I'm trying to remember, but I think in a bit it won't even be allowed. But we'll see. So is that good? That all good there? Let's try. Now number 4, on number 4, could I just grab the bottom one and flip it up? Yeah. Because there's not two things down there, huh? So just do that. Just flip it up. Right? You see the difference? When you can do that, when you can't? Has everybody seen that? So on number 4, there's just one fraction on the bottom. See up here I said when there's 2 terms on the bottom, then you got to do the hard thing. Right? But if there's just one thing, just grab that thing and just flip it up. Get 2/15 negative. Flips upside down. Right? Dividing is just upside down multiplying. Right? No problem. Now if there was a second thing down there, if there was like a 5 down there or something, then I would have to do it the hard way, right? I'd have to multiply everything by the common denominator, which would be 10. 10, 10, 10. I have to do it the hard way, right? So, but there's not. It's an easy one. So, great. We'll just do that. So, how do we... First off, it's going to be positive, huh? Because 2 negatives make positive. Be good to there. Now what do we do with all these numbers? Cross cancel, huh? Yeah. 2 goes into 10 5 times. 3 goes into 15 5 times. So what's our answer? 1 over 25. That's right. Because everything's gone from the top. That just leaves a 1. And 5 times 5 is 25. Is that making sense? Is that okay? See the difference then between 3 and 4? So if you have more than one item on the bottom, added or subtracted, then you got to multiply everybody by the common denominator. That's a little harder.
Can you explain why it turns into 1?
Well, what turns it? Oh, why there's a 1? Yeah, good question. Yeah, why is there 1? What if you had the fraction 2/6? Think with me, because did everybody hear his question? Oscar's good question. Because a 3 went into 15 5 times. It's like there's nothing up here. Why did I write 1? And 2 went into 10 5 times. That's gone. Why did I write 1? Well, really, if you think about it for a second, that's what we've done all along. When say you take a fraction like 2/6. Let me make it a little bigger over here. Now, what do? 2 goes into 6. How many times? 3 times. See how there's nothing on the top, but we don't say the answer's 3 or it's 1/3, isn't it? Because really what's happening there is we're really dividing top and bottom by 2. We just don't show all that because it gets a little tedious. But that's really what's happening. We just cross stuff off. But really, we're dividing both of them by 2. And 2 divided by 2 is 1. That's really what's happening. That's why we put a 1. Because really back here what I did, if you want to be thorough, it just gets too cumbersome. I divided both of those by 3. And then I divided both of these guys by 2. And so 3 divided by 3 is 1. And 2 divided by 2 is 1. That's really the reason why there's a 1. So try number 5. So is number 5 an easier one or a harder one? What I mean is, can we just flip the bottom up? Or do we have to do the harder LCD thing?
LCD.
It's a harder one, huh? Because we have 2 things on the bottom, added or subtracted. That's the Costco glue. It makes everything harder, yeah. So so we can't just flip up the bottom. It's not allowed. So what are we going to do then? The LCD, we're going to multiply all 4 terms. You see if there's 4 terms. There's 2 things on the top, 2 things, all right, 2 things on the top, 2 things on the bottom, 4 terms. We're going to multiply all 4 of them by the same thing. It's got to be the same thing top and bottom of the fraction so you don't change it. We're just changing the way it looks, but we're not changing its actual value, right? Plastic surgery, I always thought. We're removing the wrinkles, but we're not changing the actual value. So we're multiplying all by the same thing. What is the common denominator? It's just A. Yeah, the only denominator is A. So just multiply all 4 of those by A. Yeah. I'll bring it up here so it's B over A plus 1. B over A minus 1. I'm going to multiply all 4 by A. A. And that's really, A over 1. I just don't always show all that stuff. But any whole numbers or whole letter is over 1. So these cancel. So that's going to equal B. Am I going too quick? You're already there? And this 1 times A is just A. Good so far? The bottom, A over 1 again, cancel. B. And 1 times A is just A. Hey, what are we even doing here? Maybe I do algebra for a living, night and day. So I should say, hey, why are we even doing this? We're cleaning it up. I don't know if maybe I didn't say that. We're simplifying, right? See how it was kind of ugly? Fractions over fractions here. We call that a complex fraction, fractions over fractions. We don't like that. That's just messy. Now what have we done? We made it a simpler fraction. It's now just a regular fraction instead of a complex fraction. That's what we're doing. That's what the purpose of this section is, how to clean them up. Why would we want to do it? Well, when you do engineering and physics and stuff, things come out ugly and you want clean answers. That's what it's about. Can we simplify this at all? Can we cancel the B's and the A's, or yes or no, some of it, none of it?
No.
What's the story?
Costco.
Costco says no. We good? Right? When things are plus or minus, that makes them a package deal. Like Costco, right? You buy the whole package or none of it. right? So in other words, this B plus A is saying we're a package deal. If you want to go like that and buy the whole package, you could do that, but don't be taking just the B. And I can't buy the whole package because the whole package doesn't exactly match the bottom, so I can't cancel the whole package, so I can't do anything. I'm just done right there. Is that good? Questions on that one? All right, you want to try, here I'll move it over for number 6. It comes up in higher math and science. So take that big ugly complex fraction and clean it up. Make it just a regular fraction. Is that the easier kind or the harder kind? Yeah, it's got 2 things on the bottom added. Two terms added or subtracted. I can't just grab the bottom and flip it up. I got to do the harder way, which means you're going to multiply all 4 terms. There's 4 of them again, right? You understand that there's really only, is that true? I'm the main word. How about that? That's for sure true. The main word that I use in math. I'm really not into the lingo. But one word is very helpful, and that is terms. I'll say that one a lot. Terms are things separated by pluses and minuses, glued together also, as we've talked about, but separated also. So there's 2 terms on the top, 8 and then that other fraction. There's 2 terms on the bottom, the y and the other fraction. So we have 4 terms altogether. I'm going to multiply all 4 of those terms by the common denominator. What is the common denominator? Yeah, the only denominator, y minus 4. So y minus 4, y minus 4, y minus 4, y minus 4, exactly. Take it from there. Give you a second. Okay, so so what do we get? We get 8y. I'm going to put the 8 in the front. Doesn't matter, front or back, same thing. Plus, these cancel. Regular 8. Let me slow down there. Do you see what happened so far? So it's just 8 and y minus 4. And then the other y minus 4 is canceled. Huh? Now for the denominator, it's going to be, what is this, y and y minus 4 here. And then these guys cancel because it's over 1. Just like that one. So plus 3. Good there? Everybody seeing what's happening? Is that good? Now what? All right, so the big Costco shopping question. Can I cancel those y minus 4s? You guys are going to break the rules in Costco if you think the answer is yes. So remember, what's the rule here? Plus, yeah, that's what we need to do. Yeah, and so that's what we will do. But let me, real quick, because I know some people sometimes do wrong things. Let me say what you can't do, but then you're right. We'll go on and we'll distribute. Why? Why can't you cancel those? This is glue here too, isn't it? Which means this whole thing is stuck together. Which means if you want to mess with it, you go like that or you don't do anything. Right? That's all one big glued together package. You getting the hang of that? Pluses and minuses anywhere, glue things together, make it a package deal. All or nothing. So if you were to cancel just those parts, you'd be breaking up the package. You can't buy part of the package. It's all or it's nothing. All right, so that's what we don't do. Let's do what's right then. So it's 8. Yeah, we distribute. Yeah, just go ahead and distribute, gather like terms. That's totally right. So do that. So just distribute that 8, distribute that y. That's totally right. What do you got? 8y minus 32 plus 8. On the bottom, this is going to be what? Y squared minus 4y plus 3. Is that good so far? Can we do any more?
Yes.
What do we do?
Negative 32 plus 8.
Good. Minus 32 plus 8. That's going to be something. Minus 6. Oh, 24. 24, you're right. Minus 24. Good. Are we done there?
No.
No? Why not?
Because 3 goes into 24.
3 goes in. Okay, yeah. So can we go 3 into 24? 8 times, like that? What does Costco say? They're still plus to minus. No, Costco says, If you want to mess with this, you go like that, or you do nothing, right? Again, pluses and minuses, package deal. So we can't just do the 8y, or the 3 and the 24. They're part of packages. So we can't do that. Well, so are we just done then? Factor, good job. Remember, that's how we get around the Costco problem, is we factor. That's why we did that whole chapter on factoring. It's factoring from here on out, pretty much. I think I was saying that last time, and yeah, so a lot of factoring. So how do you factor that? How do you factor this top? Take out what's in common. Take out the 8, right? Is that good? 8's in common. How do you, whoops, I kind of messed up the bottom. What was it, 3 there? Okay, so how do you factor the bottom now? Do the diamond thing. Yeah, remember when you have 3 terms, you do the diamond thing? They multiply to be plus 3, add to be minus 4. So multiply to be plus 3, add to be minus 4. What times what multiplies to be 3 and adds to be negative 4? Yeah, good job. -1, -3, huh? Those two numbers multiply to be, two negatives multiply to be positive, and they add to be -4. That's the ones. So we get y minus 1, y minus 3. We good so far? Now, can we cancel anything? Finally, we're doing that. That's okay. We're taking the whole package. That's correct. So the final answer then is just 8 over y minus 1. That's a long problem. So there's the final answer. So we had to multiply top and bottom by all 4 terms by the common denominator. Then distribute, gather like terms, then factor top and bottom. We cleaned it up a lot. It went from a big ugly mess to that simplified fraction. We're just learning the language of algebra, which is what science and engineering speak. We good there? Questions on that? All right, so try it out. And this is number 7. Yeah, number 7 there. Clean up that big, messy, complex fraction. One of those where we can just do the easy way, where we just grab the denominator and flip it up, or is this the harder? It's the harder. How do we know it's the harder again? How do you know which? If you got adding, subtracting in the bottom, basically. If you got the Costco glue thing in the bottom, then that's 2 terms glued together. You can't just flip them. So, okay, so we're going to do common denominator. You're getting the hang of the common denominator? Let me just look at the denominators. This is a denominator, and that is a denominator. So, y. Y is the common denominator. It's the only denominator. So what do you do with it? Everybody gets one. You got to do equal treatment so you don't change the fraction. Multiply top and bottom, all the terms, by a y. All right. So now what happens from there? We'll do our cancel thing. This is over 1, so these cancel. So that's x plus 5y. On the bottom, this is over 1, and these cancel. X minus 4y. And that's it. There's nothing more we can do. Is that good? We can't cancel those x's, right, because they're glued together packages. And so that's just it right there. Nothing more can be done. All that. Is that good? Questions? All is well? All right. So let's... All right, so try that. It's kind of a mess. And let me write it a little bigger. So it's hx plus hn over x squared minus n squared all over x plus n over x minus n. So there you go. Try that one. Is that an easier one or a harder one? Do y'all see that that's an easier one? That's actually one you can just grab the bottom and give it a flip, huh? Do y'all see what I mean? There's only one fraction on the bottom. That's one term on the bottom, one fraction. There's not two fractions added. There's not like a plus x over n or something like that, right? Did y'all see that? So you can just grab that one term, one fraction on the bottom, just flip it up. You don't need to do a bunch of LCD multiplying. I mean, you could. It's okay. It's not wrong. It's just we can do the quicker thing. Y'all see that? See the difference? Let me go back and see the difference. See how on this last one, there were two things on the bottom separated by a minus, two terms on the bottom? So terms is the most valuable word in algebra. Terms are things separated by pluses and minuses. So see if there's two terms on the bottom, then you got to do the long way. This is just one fraction on the bottom. So just flip that thing. Just give it a flip. See if you can get it from there. All right, so I'm just going to grab that thing and flip it. So, whoops, that's not what I meant to do. So this will become hx plus hn over x squared minus n squared times, and then this thing is just going to flip upside down, x minus n over x plus n. See how I flipped it upside down? Just dividing is upside down, multiplying. Okay, so now, what do you think we do now?
Factor.
It's a bunch of factoring. Do you see how it's a bunch of factoring? See how this and this both need to be factored on that? That's why we did all that factoring chapter. So that numerator, I can factor out. How do you factor this numerator there? Take out the h. Oh, yeah. And how do you factor this? It's a double-double. X plus n, x minus n, difference of squares, they call it. And then just bring the other thing down. Like that. Good to there. See how I factored? We're always factoring, huh? That's how we get around the Costco problem. As we factor. And now what? Now's the easy part. Now you just cross cancel. X minus n, x minus n, x plus n, x plus n. What are we left with? Just h over x plus n. How are we doing? We good? Questions on that? All right, I'll keep moving. Okay, so try that one. Number 9. So is this an easier one or a harder one? Harder because we have the plus and minus in the bottom. Huh? Got two terms in the bottom. So you know that means we have to multiply by the LCD. So figure out what the LCD is. How do you find an LCD? Well, you look at the denominators. Here's a denominator. There's a denominator. So what's the common denominator? Y squared. Yeah, so remember with common denominator, you want the height. It's the opposite of GCF. It's exactly the opposite of GCF. I know you guys are kind of used to doing GCF a lot and think that way. So we want the higher power, not the low. It's y squared. It's common. So you're basically finding something that the other ones will all go into. That it's a container. Does that make sense? So when you do an LCD, you always want the highest power. Oh yeah, that's right. I gave the shopping analogy, right? Remember that? I said you're going to the store. It's all shopping, it seems like with me. But I said you're going to the store. You're going to buy one of each type, the highest. Didn't I make that analogy for that LCD section we had? So yeah, it's the highest. It's the highest. So that means it's y squared, y squared, y squared, y squared. All of them. Common denominator is always. It's the opposite of factoring. Okay. And you take it from there, cross cancel, and bring down whatever's left over. So right here, let's just do part by part. Right there, that's just 2y squared, nothing amazing there. What's happening right here? You always put that over 1, huh? Anything, whole numbers over 1. And then we cross cancel. This cancels one of those y's, leaving 1. So it's plus 4y. Is that okay? Did y'all see what happened there? Right? That y canceled out one of the y squares, leaving an extra one, 4y. So on the bottom down here, so y squared times 1 is y squared minus, and then this is over 1, these cancel, minus 4. Good. Already it's just a normal fraction. Already it's a little cleaner. It's just a normal fraction now, instead of fractions over fractions, which it started out being. Can you finish that from there now? Got a factor. Yeah, no surprise. So now, right, because we can't cancel anything here, can we? I cannot cancel these y squareds or numbers or anything because it's all glued together. Costco packages. So the way to get around that, factor. So factor the top, factor the bottom, and then you can cancel. Factoring comes before canceling. It seems like always. So this is going to equal. How do you factor that top? 2y squared, and yeah, take out a 2. Just take out a common 2y, huh? 2y times y, and 2y times 2. Good to there. Now how do you factor the bottom? Double double, y plus 2, y minus 2. And then these cancel. What do we got? 2y over y minus 2, and we're done. Why? Why can't I cancel? It's because the bottom is a glued package. All or nothing, I can't take it all, so I take none. This pretty comfortable? Questions? So that one, what was different about that one is we had two different denominators, y, or right here, y and y squared. Common denominator is the highest power. So is the highest power when you have two letters like that. Okay, is this an easier one where I can just grab the bottoms and flip them up? No, we got a minus. It's a harder one, huh? It's a harder because we have a minus sign on the bottom. So that's two terms. So it's a hard one. So we have to multiply everybody by the LCD. Look at all the denominators. Here, 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 and here. Those are all the denominators, so we have to have a common denominator. What's the common denominator? Just HB. You don't need h squared, right? Are we okay with that? Remember how you do common denominator? You just buy one of it. It's like I said, you're going to start, you buy one of everything, the highest you see. So just a single H, a single B. So H and B. So that's the common denominator. So HB here, HB, all four spots. All four. Because that's the common denominator. Common denominator is one of every type, the highest power you see anywhere. So put that over 1, cross cancel the h's. What's left? B squared. Good so far. And over here, over 1, cross cancel the b's. H squared. Is that making sense? Just cross cancel and multiplying what's left over. On the bottom, the h's cancel, b squared. Next one, over 1, the b's cancel. Like that. So what have we accomplished? Well, it went from being fractions over fractions, ugly mess, to just a normal fraction. Can we do any more? Can I cancel the b's and the h's? No, they're not the same, and it's got a minus. So, well, we can factor though, right?
Yeah.
Go ahead and factor it. Finish it from there. That's how we get around the Costco problem. Factor and finish from there. Okay, how does the top factor? B plus H. B plus H, B plus H? Really important that you know that. That's not right. Remember me making a big deal about double. I mean, I'm sure you know it then, but it's been a couple weeks. And there's other things in your life other than math, I'm assuming. Yeah, so I mean, that's why you got to practice and stuff. Anyway, yeah, you can't, that's not bad. It sure looks like it, doesn't it? It just kind of looks right. It's not. If you FOIL this out, you will get the b squared, you will get the h squared. That part's true, but you'll also get a middle term of 2bh, which really isn't there. Yeah, so you got to watch out. Double added doesn't work. Only double minus, which means we're done. There's nothing more to do here. But I want you to see that. I mean, you can factor the bottom, but it won't cancel with the top, so why bother? Want me to show you? We're done, really. So that top's not right. If you FOILed this out, you'd get b squared plus 2bh plus h squared. You'd get that middle term that really wasn't there. It's not right. So double plus, so you really have to remember that long term. It's going to just keep coming up and up and up. So this is what I call a double. BBHH. Double plus can't be done, only the minus. So the top just stays as it is. Now the bottom, yeah, you can factor that bottom, but why bother? You can do that right there, but see, nothing's going to cancel with the top because the top didn't factor. So it goes nowhere. So you might as well just leave it here. But both of those are fine, either one. But both of those are good answers. Both are right. Neither is any more simple than the other because nothing canceled. Does that make sense? On a multiple choice test, exam 2 in a couple weeks, either one is right. They're both right. Is that good? Questions on that? So I'm going to leave that.